Hey everyone, in this video we are going to go over how to transform graphs, specifically the cube root equation or the cube root function. And the cube root is the inverse of the cubic function. So instead of it having that more vertical traveling cubic squiggle, it is going to be more of a horizontally traveling cubic squiggle. So the cube root, again, like I said, is the inverse of cubic. What's the cube root of 1, for instance? Well, the cube root of 1, what number times itself 3 times is 1, is 1. What about the cube root of 0? Also 0 there. They both equal themselves. Cube root of 8 would be the next one I would care for, because the cube root of 8 is 2. I don't really care about doing 2, 3, 4, 5, 6, or 7 because they're not perfect cubes, so it's kind of annoying. Cube roots we can take of negative numbers as well. The cube root of -1 is -1 because -1 times itself 3 times is -1. Same concept with -2. -2 times itself 3 times is -8. The next perfect cube is 27, which is pretty far away. So when I'm drawing my parent function, I'm not going to draw that far. So here we go. Not my best drawing. This piece here should be a little bit more noticeable that it is, in fact, concave up. And then this portion here is concave down. That makes this position a point of inflection. And as we spoke about in previous videos, a point of inflection is where your concavity switches from up to down or down to up. As for symmetry, like its inverse, the cubic function, it is an odd symmetry. So that means the f of x is equal to the opposite of f of negative x, or the negative f of x equals the f of negative x, or reverse that. All means the same thing. And our domain and range both go from -infinity to infinity. This graph moves smooth, continuous from left to right forever, as it does from bottom to top forever. What else can we see here? The limit as x approaches -infinity is basically asking you where's your y value going as we go to the left, and it is -infinity. It's going down as we go to the left. And as for going to the right, as x approaches positive infinity for the cube root of x, what's our y value doing? Also going up to positive infinity. And there we go. Well, that's quite bright. I apologize. Let's see if I could just fix the focus. Little better. Sorry guys, that was a little yucky. All right, this one here, we have another cubic function. So this time though, we're going to move to the right one and up 2. Right 1, up 2. So I can bust out my little yellow crosshair over here. That's recalibrating my center. I live in a noisy city area and it's the weekend, so if you hear a lot of noise in the background, yikes, sorry. Gets a little rowdy. Now, if this was a regular cubic, I would just go up 1 over 1, and then from 1 to 8 means you go up 1 and over 7, and then same thing, down 1 over 1, down 1 over 7. However, this is not a normal. What is not normal? That right there, A is 3, so that means we have a vertical stretch of 3. So instead of going up 1 over 1 for that first point, I'm going to go up 1, 2, 3 over 1. And then instead of going up 1 over 7, I'm going to go up 1, 2, 3 off the graph, sorry. Over 7 will be above that point I put right there, like that. And instead of down 1 over 1, I'm vertically only stretching, so down 3 over 1. So again, the cubic and cube root have that 1, 7. And then instead of down 1 over 7 that way, I'm going to go down 3 over 7. So that vertically stretched my graph. So from here until right there, I still have concave up, and then concave down. Beautiful, beautiful, so nice. Okay, next, 2 more. How are we for time? Oh man, we're getting faster and faster, aren't we? All right, here, where are we moving? Left 3 and down 1. It is the same transformation rules for everything, everything. The thing enclosing, encapsulating, housing the x plus 3 is a cubic function that tells you what the graph looks like. Left 3, down 1. And that is where you have your horizontal house, where everything inside of that is moving horizontally, right? So there we go. And then this time we have a negative. The negative out where A is a vertical reflection. So it's like folding this way, okay? Vertical reflection and a vertical stretch of 2. So not only are we flipping vertically, we are also stretching by a factor of 2. So from here, instead of up 1 over 1, we're going down 2 over 1. Instead of down 1 over 7, down 2 over 2, 4, 6, 7. Up 2, left 1, up 2, left 4, 6, 7. Off the page almost. Like that. And there you go. A little lumpy, sorry. Make the dots really dramatic so if you don't draw it perfectly through, your teacher knows what you're doing. Here, there's an invisible plus 0 right there. So what do we have happening? We have a vertical stretch of 4. We are moving to the right, 2, up, 0. Right 2, up 0. The stretch is 4. 1, 2, 3, 4 over 1. Up 2, 3, 4 over 7. 1, 2, 3, 4, 5, 6, 7. 2, 4 over 1. 3, 4. 1, 2, 3, 4, 5, 6, 7. There we go. Hope you loved it. If you feel like you can graph a cube root function, just know the difference, okay? Cube root is going more sideways. Cubic, it's going up and down more. So if you think you could do it, you get it. Thumbs up. Questions, comments, concern, go to the comments section, talk to each other, help each other. Hopefully I could help you too. The next one will be, I think, exponential, and I've already done linear, absolute value, quadratic, cubic, and square root. Thanks for stopping by. Adios.